Hi, good evening. Good morning, everyone. Let's get started today's session. Bala, you can, or Bharat, you can start the recording of this session and we'll continue. Okay, thank you very much. So let me give you a recap of what we have done yesterday. So we have yesterday started the EC2. This is Elastic Compute Cloud. And I hope everybody is able to see my screen. Can you give me a thumbs up for the screen and the voice? Is that fine? Anybody? Any challenge, or is my voice and my screen visible to all of you? Thank you, Akarsh. Thanks. Okay, I will continue. Thank you, Ashutosh. So yesterday we have seen Elastic Compute Cloud, which is the virtual machine service from AWS. We have seen what are the configuration we have to do when we have to create a virtual machine. We have created a Linux machine as well as we have created a Windows machine. And after that, we connected to both of the machine. We tried to get a feel of that particular machine. For the Linux machine, we used the putty client, and for the Windows machine, we used the RDP. After that, we have looked at the auto scaling. And we have seen why auto scaling is needed. What auto scaling is nothing but it is going to give you any kind of a on-demand capacity in comparison to whatever the workload you have on your environment. So we have seen the example of the servers, e-commerce servers, and then we have also seen the AMIs by AME yesterday. Now we will move ahead and we'll see few more things. The first and foremost things I want to show you is to how do we create, or what is the EBS volume. So let us go and create a EC2 instance. Now, as a part of today's class, I'm going to also continue and teach on the load balancers. So we will see what are the different load balancers and how we will do a load balancing. For that, I need to create multiple machines and I will do that. So I will create Linux machines and I will also do something which is called as, we will use something called as user data or a boot up script when we are configuring the Linux machine. So let us just go and create a machine. So I'm into my console here and I'm going to create a Linux AMI2 machine. I will go and select a T2 micro as a size of my EC2 instance, then configure the details. Here I can give 3 machines because I want to have 3 machines as part of my elastic load balancing. I can do that by putting 3 machines here. But by doing this, I'm going to create all the machines of the same size. So first of all, I will do one thing. I will create one machine, whatever the bootstrap or the user data script I'm going to use to create a web server on our machines. I will show it on first one machine, and then we will do it using the bootstrap for the rest of the 2 machines. So let us go and create that. So here it is. This is my first machine and I'm not giving anything here and just continuing with the default options I have selected. Add storage. I will keep the root volume as it is. When I'm creating a EC2 machine, I can add another volume to it like this. Let me just show it again. Add volume. Now, why this is needed? If I need another hard disk to my virtual machine, then I can do that by adding another EBS volume. This EBS volume size we have to specify, and let's say I have specified 10 GB. But there are different types of EBS volume based upon the use case. You can see there is certain difference in terms of the root volume which we have and the EBS volume which we'll have. So here you can see GP2, GP3, IO1, IO2, SC1, ST1, and magnetic standard. But if you go here, you can see GP2, GP3, IO1, IO2, and magnetics. That's it. You don't see another type of the hard disk, which is called as cold HDD, which is SC1, and throughput optimized HDD. Remember, when you want to use a boot volume, then only the type as SSD and magnetic can be used as a root volume. So remember that. Now this is, we are going to add a extra EBS volume on top of our machine, and I can just select the type of the volume. Now this, what is the volume? There are two types of technology here when we are trying to connect a volume or a hard disk to our machine. One is SSD based, and they have flavor of GP2, GP3, IO1, IO2. So what is those? We will just go and look at this. So EBS volume is nothing but a kind of a storage, a permanent storage, which is attached to your EC2 instance. But when you say attach it, it is attached over the network. It is not directly attached to the EC2 machine. Now this EBS volume will have a persistent or a permanent data storage. That means if you just reboot your machine, stop your machine, whatever the data which is there on that machine will not be wiped out. Remember, I have told you yesterday that if you use the instant store and if you stop your machine, the data on your machine will be wiped out. So that is not the case with you with your EBS volume. Now there are different types of EBS volume. I just talked about one based upon the technology which is used, solid state drive and the hard disk drive. Solid state drive, as the name suggests, are using a chip to give you the memory, the function of the storage. Whereas hard disk drive is having a moving part. And this is what we have in our laptop and our desktops. Nowadays, the lot of people are being pushed to go for and buy a SSD drive, which is more faster. That is what is claimed by all the people who are selling it. And actually, in fact, it is more faster as compared to your HDD, because HDD have a moving part. It has a moving part, and this does not have. This has a chip, and that's why it is faster. And that's the reason it is also costlier. And I would say you would agree with me. Now there are types I told you. So GP2 and GP3 are called as general purpose SSD. They are they will give you a balance of price performance for variety of workload. It is ideally used for a boot volume or low latency interactive app. The name is GP2 and GP3. GP3. Yeah. So difference between GP2 and GP3 is when you go and suggest use a GP2, you get a ratio of 1:3 Iops. Iops. What is that? It is input output operation per second. Iops. Sorry, this is Iops. Yeah, and this is depending upon the size of the. So that means if I go for 100 GB size, yeah, I'm going to get 300 Iops. So 1 GB memory will give you 3 Iops. And with this, if you need more Iops, you need to increase the memory of your GP2. But with GP3, what you get is, irrespective of the size, you can get a higher number of Iops. And that is very, very evident from this screen. I will show you here. You can see, so here it is. If I have a size of 100, you will see that the Iops I'm going to get is 300. You can see here. The minimum I get is 100 Iops. Yeah, if I want more Iops, I have to just go and add the volume. So you can see 3,000 Iops. But in case of GP3, if I just go and say 10 GB, yeah, I can change the Iops value. So it is not relevant. Yeah, it is not directly proportional to the Iops of the hard disk. So this is the difference between GP2. GP3 is the latest version of your the SSD volume. Now, if you go to IO1, yeah, this is called as provision Iops. The use case for provision Iops is for your database hard disk. Yeah, where you need more Iops from your storage. Why? Because you are going to do lot of IO performance on your database. And that's the reason you need to go for IO1 and IO2. If you look at this, yeah, it is going to be for high performance SSD volume designed for latency sensitive and transaction workload. Use case is for IO intensive, no SQL or relational database. IO1 and IO2. That is the latest one. Now, the other one, which is called the HDD type, it has two disk, throughput optimized and cold HDD. This is ideally suited for a network throughput kind of a workload. Yeah, where the network throughput is more important than the IOPS. Because of this, they give very, very less IOPS, but the network throughput is high for this. If I go to my here, and I can just select the cold, yeah, you can see the IOPS is not a determining factor here. The network throughput is a determining factor here. So let us go and just continue with GP2 here, and we'll go ahead. Next, and we'll use the existing security group which we have already used, which is my my Excel, this one, which has port 22 review, and I will launch, and I will use the existing key pair, launch it. Now, this is how you just install a virtual machine. Now I want to install a web page on it. So let me show you how to do that. And we will use this web page to host our application. And this will be sitting behind our load balancer in the next, whatever the 10-15 minutes, I'm going to explain you the load balancer. So let us go and connect to the machine and install it. I will re-verify whether I have the right key here. Yes, I have the right key. And I paste the IP address here. And now I'm showing you the manual way of installing a Apache web server on our machine. Now, what is web server? Web server is going to give you a dynamic website, a website for you on your EC2 machine. So, but we are going to use just HTML code in our website to create a web page for us. So here is my IP address. I will click open. I will accept. I will say EC2-user as the user ID and enter. Fine. I have connected to my virtual machine. The first and foremost thing I have to do is to update the packages I have on my Linux machine. To do that, there is a utility called yum, which needs to be used in the Linux machine. On the Ubuntu machine, there is a utility called apt-get. So the first command we are going to do is sudo yum update. And if I give this -y, then it will, whenever it prompts us to confirm whether you want to download this, this will give a value as yes, and that's why you can give -y as the attribute there. But let us go and see without it. This is the command, and this sudo is to elevate your privileges, because your EC2 user ID does not have the privileges to install the packages. So that's the reason I am using the sudo yum update, and just go enter. So it says no package marked for update. That means there are no packages. The version of the AMI which you are using is having the latest. Now to install a package, we have to use another command, which is called as sudo yum install and the package name. So in this case, we are going to use the Apache web server. So we have to install a package called Apache. The name of that package when we are using it on Linux AMI is called as httpd. Now, again, I am not going to give the attribute of -y. I will simply go ahead and try to install the package here. And you can see, is this okay to install? I have a choice of Y, D, and no. Yeah. So I'm going to just type in Y and it will go and install it. So here is my HTTP package installed on my machine. Now, how do you see whether the package is installed or not? I can check whether the service is running. So sudo service status or status HTTPD. Yeah, and this will show me the status of the service. So it is saying, yeah, uh, it is saying for other, please try systemctl. The service command support only basic. Okay, that's fine. It is asking me to use another, so I can try that. Try that as well. Let me just change the format of it. Sudo service status. Yeah. So I can also use something called as systemctl. Yeah. Sudo systemctl HTTPD status. That is also will work. So in this case, it is showing the service is inactive. Now, to make this service active, we have to start it. So let us go and do one thing. Yeah. So let us start it. START and enter. So it is saying, yeah, start it. Now let us go and use the command again, status, and it's showing it is running. Now, whenever you install this Apache web server, it is creating a folder and an index.html for us. Yeah. So which is the default index.html. Where it is creating? It is creating somewhere here. cd/var www.html/. Yeah, this is the folder. If you are not able to find this folder, that means your package might not be installed. If I have run this command before I installed the HTTPD, then it would have given me a error that folder does not exist. And if I do a ls here, it is not going to show anything, but it is going to have a default web page installed on this machine. Now, how do you check whether the default web page is there or not? We have to use the IP address of our machine and put it in our web browser to check whether the page is loading or not. Now, in this case, the page will not load. Now, why? Because for this HTTP or the web page to work, we need a port number 80, which is used by your web server, and that is blocked from our security group. So how do you enable? I am going to use the same security group and I'm going to edit it. Let me go and edit it. Here is my security group. What I did, I went to my EC2 machine. I clicked on the security tab. And if I just click on my security group, it will open a new tab. So this is how you go and edit your security group. You can edit your security group after you add it to a machine or before adding as well. So here it is. I'm going to edit the inbound rule and add a rule. So the web server works on HTTP service and it uses the port number 80. So I will use type as HTTP. I can type in like this here and it will take a port number 80 and I will open it for the world. Now I will just save it. By doing this, let me first show you whether it works or not. So just a minute, let me paste it and whether it opens or not. So it will simply time out. Yeah, so it will time out. And as soon as so it will let me time this out. Okay, it is not opening and it will not give any result as such. Okay, let us wait for this to time out. What I will do is I will add this rules. Okay, for port number 80 and say save. As soon as I do this and I go and so this is timed out. Now this is added. Let me just do a refresh here again. And you can see that the test page for my website is showing. This is the default web page, which is showing Apache. This is how you install a Apache web server. Now, there are certain things you have to do to make it a customized page. So we will do that. Before that, I want to ensure that whenever my machine reboots, this HTTPD service is turned on. So let me enable that as well. Okay, so for this, we have to use a command, something called as check config, chk config HTTPD on. Yeah, what it will do, it will, whenever I reboot my machine, this command will check and turn on the HTTPD service. Yeah, and it's saying it failed to execute. Why? Because I need a sudo privileges. Here it is. And now it says yes, forwarded, created a link, and so on. Fine. Now, what I will do, I will whatever I am doing, I will help you out. What I will do is I will simply um, get a what you can say customized page for us. Okay, so let us go and do that. How do you do that? First of all, I need to have an index.html page created in this folder, which is the default path for our machine. For this, I need a elevated privileges. I will simply go into the elevated privilege by using a command sudo -i, which will take me to the root prompt. Okay, this is basic Linux things which you have to use, very basic commands, which will help you to do that. Okay, so just a minute. Okay, so I have elevated my privileges, and now I will go to this path cd/var/www/html. Yeah. So if I do a pwd, you will see that I'm at this folder. Okay. So whatever, these are the very basic commands. This will show you the present working directory, and this is how you navigate to a folder, the path. Now here I will create an index.html. Let me check whether I have a file here. I do not have. What I will do, I will create an index.html. How do I create? There are different ways to create it. I will use a one-liner command, like which is the echo, and then I will paste a small code into it, a HTML code. A code is something like this. I will just paste it. Yeah, this is my fun web server, and I will close the bracket and this, then yeah, and then index.html. So this is how I am creating index.html as a web page. And in that index.html, I'm putting this HTML code, which will give me this as my web server. Yeah, page, landing page. Fine, enter, done. If I do ls here, I can see that there is an index.html. And if I do a cat to see the content of index.html, I will see that this is the content. So as soon as I do this, I will go and refresh my web page. Let us go and do that. So you can see now this is my customized web page. So this is how you create a complete web page. So let me give you the complete script for it. This is a script which is going to be used. Now, here it is. I will pass on the script in the chat. Now, all these commands which I have just given you, you have to just append a sudo in front of it, because this is expected that this command should have a elevated privilege. Other thing what you can do is just elevate your privilege by using this command sudo -i. But this is not going to help you in a real life scenario. Why? Because the root privileges are very restrictive. People will not get access to the root privilege, and that's the reason you will not be able to perform this. So a better way is to use elevated your privilege, or ask somebody who has elevated privilege to get the things done for you. Okay, so this is my one web server which is ready. Now I told you I want to have multiple web servers. So let me show you another way of getting this thing done, what we have just done, using the automated way. So I will launch 2 more web servers. Select. Again, I'm launching a EC2 instance and selecting the T2 micro. Now this time 2. But now what I will do, I will use something called as user data. Now this is user data is nothing but a automated script which you run whenever you log in or whenever you installed your machine. The script, whatever we mention in here, will run only once when you are installing the machine. So let me do that for you. Okay, now I will add some kind of what you can say uh, automation to it in terms of getting some values specific to the particular machine. For example, I will try to find out in which AZ this machine is and what is the IP address of this machine. That can be done by using a bootstrap script like this. Okay, and it is doing the same thing what I have given for the other commands just some time back. To initialize the bootstrap script or user data, you have to initialize the bash by using this commands and then write all the commands. Remember, these commands will run without any human intervention. So you have to take care of this. Now I am using the yum update, which is nothing but it is going to update the package. Then I'm going to install the HTTP package, start the HTTP package, enable it whenever it is trying to, whenever you reboot it, the machine, it should by default start the HTTP service. Then I am using one environment variable, which is which is uh, which is getting the data of the availability zone from a service which is called as metadata service. Yeah, this is called as IDMS, instant metadata service, which gets this data from this IP address, which is the same IP address on each and every EC2 machine to get various data for your machines. Okay, so I'm getting the zone, availability zone information, and after that we are going to uh, get the host name and put this value into our index.html page. This is what we are going to do. Okay, so be careful when you copy paste this. If this whatever the script you have written, if it is broken, then it will not install all those things. So let us go next. Add tag, configure security group, use the existing security group, which is this one. Yeah, and review and launch. Okay, so let it launch. We'll wait for it. Okay, so 2-minute pause. So if you have any questions till now, I can just take in the chat. Okay, so I'll give a couple of minutes for you. Please go ahead and put your questions in the chat. It's there in the chat, but I can just give you like this. Just go on to the website and say putty download and you will get the link for it. Here it is. Paste it here. Okay. Fine. So that's it. Okay. So nobody, I think nobody has a question today. Fine. Let us go ahead. Let us see our machines are created or not, and we'll continue. So here you can see my 2 machines are getting created. And now we'll move to the next section, which is the load balancer. Yes. So I have just shown you how to set up a web server on a Linux machine. So now what is load balancer? So just one question from Eva. From this, if you want to use a putty, you don't have to go and you use that from the EC2 instance. You have to open the client like this, and then from there, like this. So you will have, if I have to open a new session, you'll open a client like this. You go into SSH, check the auth, and the path should have your PPK file. If that has it, go to session from your console. From your console, take the IP address, put into the here and connect it. That's it. Yeah. Other ways you can connect it from here and use the SSH client this command. But this for this you need to have a CLI, bash CLI to connect. Fine. Okay. So what is load balancer? Yes. So load balancer is a device which will help you to divert your traffic to a group of machine, yeah, which are sitting behind that particular device. That device is called as load balancer. What it does, it automatically distribute your traffic to different devices or endpoint which are sitting behind your load balancer. And in this case, we are going to see it for our EC2 machine. So your elastic load balancer will distribute your incoming traffic, application traffic, across multiple target and virtual appliances which are sitting in one or more AZs. Another feature of your load balancer is you can also monitor the health of the multiple targets which are sitting behind your load balancer. That is also can be done. Now this load balancing can be scaled, okay, based upon whatever the traffic you are expecting on your environment. That is also possible. Okay. So within AWS environment, you have 4 types of load balancer. Those are classic load balancer, application load balancer, network load balancer, and gateway load balancer. The classic load balancer is the generation 1 or version 1 kind of a load balancer, which is not recommended now, and you can if you want to run your production workload, then you should go for the 3 of them, not the classic load balancer. So this is good for your a demo or your test environment. Now, what is the use case to use your load balancers? What is the choice you have to make when you go for different types of load balancer? So every load balancer has a particular functionality, yeah, and you will have the particular protocol and a certain layer of the OSI model where it will work. So we'll look at all those one by one. So let us look at classic load balancer. Classic load balancer is a load balancer which will help you to route your traffic to the EC2 machines only. Okay, remember EC2 machines only. They will route your traffic to your EC2 machine, so that, and it will use the protocol as TCP or TCP UDP with SSL or TLS enable on it, and as well as HTTP and HTTPS protocol. Now, what is this? This is the protocol on which you are going to listen to the traffic which is coming from your various machines. So this is 1, 2, 3. So these are generating traffic. And suppose your a web page or e-commerce site, yeah, e-com site is hosted on these machines. Now, what will happen whenever the traffic is coming from all this machine? It will be diverted to the bunch of EC2 machine which are sitting behind your load balancer, and it will equally distribute the traffic to your machine, so that even if one machine fails like this, the 2 machine will be able to take care of the load. This can be helpful to avert any kind of a downtime on your environment. So this is the load balancing for you. And if you use this protocols, the HTTP, HTTPS, and TCP UDP, with limited features, then you are actually using the classic load balancer. With classic load balancer, the target type for this will be only EC2 machines. Okay, EC2 only. How it is done, I will show you later on. Okay, so this is classic load balancer for you. Then we'll move to another load balancer, which is called as application load balancer. Now, application load balancer is quite an advanced load balancer, which operates at layer 7, with 7th layer of your OSI model. Now, what is this OSI model? This is the model which defines how and at what level your particular application or your particular protocol will work and so on. If you need more details on it, you can just go and follow this link, OSI model layer, and understand more about it. Okay, so here it is. You can just give the layer, and okay, this is the layer for the OSI, and here you can see. Then I can say that application is at the layer 7, presentation is layer 6, 5 session, 4 transport, 3 network. So our application load balancer operates at layer 7. So let me put that in the chat for you. Yeah, fine. Let's go to the theory part. Now what this does, it uses two protocols. What is the protocol? HTTP, HTTPS. Why? Because it is operating at layer 7, and layer 7 will talk to your application only on HTTP, HTTPS protocol. Now this load balancer has many capabilities. For example, you can have multiple types of routing based upon the URL. It can route based upon the URL. Okay, it can route based upon the header which you have in your URL. It can also be routed based upon the path, and it can also be based upon certain different attributes as well. So this is very advanced kind of a thing. And with this application load balancer, we can have multiple target group attached to your load balancer. This is not possible with your classic load balancer. So yeah, so okay, so this is what the elastic load balancer will do. Yeah, with elastic load balancer, you can also have a health check. This is also possible with your classic load balancer as well. So this is how. So if you want to have multiple target groups attached to a load balancer, in case of a classic load balancer, then you have to use multiple classic load balancer. But the same thing can be achieved by using one load balancer in the application load balancer. So this is application load balancer for you. Now the third is network load balancer. Network load balancer operates at layer 4 of your OSI model, and it supports TCP/UDP protocol. So whenever we create an application load balancer, it creates a DNS endpoint for us. DNS endpoint for our application load balancer. But when you use network load balancer, it creates an IP address for us, not a DNS endpoint for us. Now, this network load balancer is useful when you have millions of requests hitting your application load balancer per second. And it will be able to support your millions of requests. That is the beauty of your network load balance. So remember one thing, it operates at layer 4, it supports TCP/UDP, yeah, and it supports million of requests. It will able to move your data from particular endpoint to your target, which are sitting behind the network load balancer. In both cases, in your elastic load balancer and your network load balancer, you can have multiple types of target group. You can have a EC2 instance as a target group. You can have an IP address as a target group. You can have a Lambda function as a target group, and you can also have a application load balancer as well as your target group. So we'll see that when we do the practical, I will show you that. So this is your network load balance for you. Then we have a gateway load balancer. Gateway load balancer is a load balancer which helps you to utilize third-party virtual appliances, virtual load balancer or appliances like firewall, any kind of a intrusion detection, and any kind of a packet inspection system as a load balancer for you. So this will support third-party load balancer for you, and you will be able to use a gateway load balancer for it. This operates at layer 3 of your OSI model. So we are going to do a practical of application load balancer as well as classic load balancer. And we'll not do that for the network and gateway because both of them are not part of the free tier. Only classic and application are part of the load balancer, the free tier. Yeah, I have a detailed list of the comparison. So here you can see it is layer 7, it is layer 4 here, and the classic operates at layer 4 and layer 7. Target type, you can see IP, instance, and Lambda. You can also have a ALB as a target here. Yeah, same with this. And with this, you can only have your EC2 instance as the target. Here you can have a IP and a IP or an instance, EC2 instance as a target group. Then there are various features which you can just go on this link, which I have just shared here in this, and you can look at the details about it. Fine. So let us go and do a practical of this load balancer. So our 3 machines are already set up for us, and we will use those machines to be part of our load balancing. To work with your load balancing, what we have to do, we have to go into this EC2 instance screen, EC2 dashboard screen, and scroll down below. Once you scroll down, you will see the load balancing option. Let us go and click on the load balancer. So once I do that, I can have an option of creating a load balancer. So we will create a classic load balancer, and then I will take questions from you. So create a load balancer. This is what you have to do. And you will see all the 4 types of load balancer: application load balancer, network load balancer, gateway load balancer. And classic is the below one, which is the previous generation. So let us go and see the previous generation, which is classic, which is easy to understand, and we will be able to follow it quickly. Go there, create it. Give a name to your load balancer. My ExcelR LB demo. This is the name. This your load balancer will sit under your VPC. I can make this load balancer as public facing or internal as well, which I can do it from here. If I don't check this box, it will be a public load balancer. Okay. No, only classic and application load balancer can be in the free tier, and that too only one quantity each. Chandra. Okay, so I'm not going to do that. Now, these are the settings you have to do. Okay, so let me take a drawing here and show you what is this. So here it is. So suppose this is your load balancer, and these are your virtual machines which are sitting behind your load balancer. And let's say you have some users who are hitting the traffic here like this, and the traffic will come onto your load balancer at a port which is called as load balancer port. This is the load balancer. This is the port 80. So your traffic will come on this, yeah, and then the traffic will be diverted onto the machines, like this, like this, and like this. Now this is your listener port on the load balancer, and here also you need to have a listener port, which is again port number 80 in this case. You can see here. So this is the instance protocol, and in this instance port which you have to define. So it is also going to listen on the port 80. Why? Because our web servers are going to be hosted on this EC2 machine, and they also listen on port number 80. So whenever traffic comes, it will go and hit this port, and then it will be diverted to this, and like this, like this, like this. So I can show it in another color. It can go like this, it can go like this. So this is how your traffic will be diverted. Now in this case, it might be a round robin. Okay. Yeah. And on a best effort basis. So this is what we are configuring in the listener configuration. So I am going to just keep it as it is. Then I have to go and add a security group. Let me use the existing security group, which I have already selected, created, which is my this one, ExcelR SG. Okay. Uncheck the default one. Don't select that. Yes, next. Then it is saying that your load balancer is not using a secure listener, which is right. We are using HTTP port, not HTTPS. So why? Because we don't have the SSL certificate on our web server. So I'm fine with that. Then I can set a health check. Now, what is this health check? Okay. So if I go into this now, suppose this machine, okay, it is not working properly. Yeah. So suppose this machine failed. Okay. So what load balancer does it? Whatever the traffic which are coming, he will not send the traffic to this failed machine. Yeah. And this is done by using a health check. How the health check is done? The health check is done by continuously, what you can say, let me look at size, continuously doing a ping on the web page, the index.html web page. It will do a continuous ping and ascertain whether the web page is live or not at port number 80. This is done by using the health check. So here we are specifying the ping port, yeah, and the index.html as the page. And then there are certain values which will govern whether this is healthy or it is unhealthy. Now, this is if your machine is healthy, there is one parameter which is called as healthy threshold. This is nothing but the number of consecutive health check successes before I can declare my machine as healthy. So if I put a value of 2, then it is going to check twice consecutive. Yeah. And if I get a response from that machine, then it is healthy. Same goes for unhealthy. If I don't get 2 consecutive health checks, yeah, that means my machine is unhealthy. So this is unhealthy threshold. Then I have an interval value. So this is nothing but amount of time between the health checks I am performing. So I can set a value of 10 here, which is very, very minimum. I can set 5 as well. So why I'm setting it minimum? Because I want to show this health check option or the health check of our EC2 machine and to happen very fast. Okay. And my health check my machine should come in a healthy state so that I can pass the traffic to it. That's the reason I'm making it very, very small. But yes, it has to be evaluated for based upon your application, and then you can put this value. Now, the last option, which is the response timeout. This is the time you are going to wait for the response to receive from your machine. And then you can say that yes, whether if you received a response in that particular time, then it will be counted as a valid response. Otherwise, it will not be counted a valid. So I'm going to put it as 2 seconds again. So now for my machine to be healthy, how much time I have to wait now? 2 into 5, which is 10 seconds, and 2 into 2, which is 4 seconds. 10 plus 4 will be 14 seconds. I need at least 14 seconds for my machines to be in a healthy state. I repeat again, how many healthy thresholds I am waiting for? 2. And what is the interval between each of that? 5. So 2 into 5 is 10. Yeah. And how much time I'm going to wait for this response to come? 2 seconds. And I will do it twice. So 2 into 2 is 4. So the total time would be 10 plus 4, it is 14. So this is the value I've set. Next. Then I need to add the targets. So in this case, my machine, EC2 machine. So I will select all of them. Here is all of them. Yeah. And okay. And I will say add tags, and I will not add tag, and I will say preview and create. That's it. So this is my classic load balancer created and it is going to route the traffic to my all the three machines. Now, how do I check whether the machines are healthy or not? I go to here, the instance settings here. Okay, and you will see that all of these machines are showing out of service. Why? Because we have to wait for certain amount of time before it can be declared healthy. So let us wait for that 14 seconds. Yeah, meanwhile, I will just try to refresh and see whether this is coming in service or not. So I am open to take questions. So if you have any questions, please throw. Yeah, few of the things you have to, okay, yeah, fine, this is okay. What I have selected, okay, I should have selected this one, which, yeah, okay, save it. Okay, so yeah, you can see my instance are showing in service now. Yeah, so that's it. So these are showing in service. Now, how do I check whether they are doing a load balancing? So each of the EC2 instance has a web page which we have configured by using our bootstrap. Yeah, let us go and try to use that. To check our load balancer, we have to use a DNS name. This is the DNS name for our load balancer. Let us copy this on the description page, put into our browser. And ideally, what should happen? I should see the landing page of the EC2 machine. Here it is. Once I do that, yeah, it should show me the web page. Okay, let us wait. Instances are showing in service, web page. Okay, yeah, let us wait. It should show immediately. Meanwhile, if you have any questions, please pass it. Ideally, it should not take so much time. Okay, so before we go there, let us, okay, connection timeout. This is very strange, but let us go and verify it. Okay, what we have to check. Okay, so our EC2 instance are in service. The one thing which we have to do is, okay, we will see whether the web page of our machines are actually opening or not. These are the three machines. The first machine we saw when we created was giving us a web page. Let us go and I should refresh it actually, so that I think it should come up again. First and foremost testing I can do is go on to individual machine and check the web page. So this is showing, yeah, this is opening. I will check the other machine, copy, paste it. Opening, very good. One page and the third machine as well. Paste it and it should also open it. Now, what is the problem happening with this? Very strange. It should also open. Take the IP address, copy it, take this DNS name. I will use it another window and try to paste it. Okay. There is no, I would say, there should not be any issues why this should not work, but let us go and troubleshoot it. I have added, okay, can you see what I have added here? RDP SG allow. Okay, this is not the right security group. Why it is not? Where is my ExcelR? Why it is not showing in this? Okay, here is the name of my ExcelR. Okay, let me just go and select this. That's the reason it is not working. Okay, save it. And now it should work for me. Yeah, here it is. Okay, so it is a confusion between the name which has created this issue. Now you can see on this DNS name, my web server is working fine. Let me refresh it. Now it has gone to the another machine. If I again refresh it, it will go to the other machine, another IP address. So this is how the load balancer should work. Again, it went to the first, again the second, again the third. Yeah, so it is working as expected. Okay, so very simple thing, nothing complicated here. Okay, we should have this security group as our security group. Why? Because it has port number 80 and port number 22 open in it, and that's how it should work. So I'm open for a question. We will take a question for next 5 minutes and then we'll start again. Okay, so if you have questions, please pass it on and I will try to answer it. Yeah, is there any issue with the security group? Yes, there was. Actually, we selected a wrong security group. Yeah, got confused with the name of the security group. We have added a security group of RDP, which has port number 3389 and which will not work because we need port number 80. Okay, fine. So I'll be on mute for next 3 to 4 minutes. If we don't get any questions, we will start again in 2 to 3 minutes. Fine. Sure, Prasanta, I will explain you the load balancer again. Load balancer is a device which will help you to route your traffic to multiple endpoints, multiple EC2 instances which are sitting behind this load balancer. So what it does it in this case, it just distribute your traffic. It just distribute your traffic from this LB, which is your load balancer, to your EC2 machine, which is this one. So, and it does in kind of a round robin fashion, like this, from here to here to here and so on. That way, even if your one machine is down, it will not create any issues. You will be simply able to run your application on this. This will work in case of a distributed environment only. So distributed environment is like your web servers, web server. Okay. I hope that answers your question. Rohit, so Apache, why use Apache? What do you want to use for a web server? Yeah, Apache is open source web server, and that's the reason we are using it. Okay, so isn't it a third-party application? Yes, it is. But for to use for a web application, you need a kind of a application for it. Yeah. No, this is so it's a kind of a package. So it is like this. Okay, you are asking, does Microsoft provides PDF for you to edit your PDF files? It is like this. So AWS does not provide it because yeah, it is not his domain. There are companies who are providing you web server. For example, Apache. Yeah, this is one of them. Then Nginx is there. Yeah, and there are so many things. Okay, fine. Okay, so if everybody is fine with this, it's a name of a company, Apache, and this is Apache web server. The company, there's a company name. Yeah. Okay. If you go and search, yeah. So it's a free open source web server. Yeah, which is from a company, Apache. Yeah. Okay. So it's an open source actually. I hope that answers your question, Adarsh. Okay. So I am moving now next. Seems people are having less questions today. So let us go and move on to the next topic. Okay. So let us go and move on to the next topic, which is like I am going to now show you a application load balancer. So we have seen a classic load balancer, how it works. Let us go and create a new application load balancer. Okay. So create load balancer. And now we have to select the application load balancer. So here it is, create. The method of creating application load balancer is slightly different because we have different type of target groups in the application load balancer. Let us give a name, Excel or ALB demo. This is the name. Again, I have a choice to use a internet facing, which is public load balancer, as well as a internal load balancer. I will go with the internet load balancer. I also have an option of IPv4 or a IPv6 IP address to be assigned to be used for this. Then I have to select the VPC. Yeah, earlier case also I have selected a VPC, and then I have to use the AZs as well. Now every AZ will have one subnet associated with it, and I'm selecting all the AZs here. So yeah, others dual stack is nothing but it supports IPv4 as well as IPv6 IP address, and that is the dual stack. Now every AZs, North Virginia has 6 AZs, and each AZ should have at least minimum one subnet. So I'm selecting all AZs here. What is the meaning of this selecting all AZs? That means whatever the load balancing I'm going to do, this will be supported in each and every AZ which I have selected. So I have selected all AZs here. Then I have to select a security group. Okay. So in this case, again, I'm going to select the same ExcelR SSG allow. Let us be very sure when we are selecting now this security group. Yeah. And then we have to use the listener port, which we have specified earlier as well. And that is going to talk on port number 80. Now, the next step is to select a target group. In this case, we don't have the option to go and directly select the EC2 machine. Now what we have to do, we have to go and create a target group. So there is a procedure for it. So we have to just select any of the target group which is available here, or if we don't have, we will create a new target group. And that is what I'm going to create now. So create target group, it will open another window. Now I told you with the application load balancer, we have different types of target group. So if I have a EC2 instance, then I will be able to use the EC2 machine within my VPC as a target group. If I select IP address, I can have machines which are part of my VPC as well as on-premise resources, my data center resources as well. So I can just specify the IP address for it. Then I have a Lambda function as a target group where I can use a Lambda as a load balancer, as a endpoint for my load balancing. Then I can do a application load balancer as well. Okay. So for the simplicity, I'm going to use the instance again. Then I have to use the protocol. So I will use HTTP and I have to give a name to my target group. So it is ExcelR TG. Okay, so this is the target group name, and I am going to use the protocol HTTP and the port as 80. and use the VPC. And again, I have to set up the health check. I have to just put a value as / to ping at the root prompt, and then the health check values. The same thing what we have done in a classic load balancer. Yeah. So here it is. Healthy threshold I will put at 2, unhealthy also 2. Timeout I will put it 2 again, and the interval I will put it at 5 seconds only. Yeah. With this, you also get an option to pass a success code for any kind of a health check response. This will be useful when you want to programmatically check whether the health check is passed or not. Okay, so I'm not changing here. Okay, and next, and here are the EC2 instance. Okay, so I'm going to select all the EC2 instance, and then once I selected, I have to click on this include as pending below. Yeah, if you don't do it, unless until you do it, it will not work. So include as pending below. Yes, so here it is. Now I have included this 3 EC2 machines in my load balancing, and I will say create target group. Now the target group is created for me. Yeah, and target machines will be shown as unused, unused, unused. Why? Because it is not associated with any load balancer. You can see here. So now let's go to the load balancing page again. And in this case, let us forward this traffic to the target group which we have. Now you might not see this target group here, so you have to just go and refresh it. Okay, refresh it, you will see your target group, and you should say select this, and that's it. Okay, so your application load balancer is set up. I will just re-verify, give a name, internet facing, IPv4, VPC, all the subnets, right security group. Yeah, then the port which is on HTTP, and the target group which I have just created for my 3 machines. That's it. Create load balancer. Now, once you create a load balancer, application load balancer, you will see the DNS endpoint for your load balancer. Here it is. But if you want to monitor your machines, whether they are in service or not, you have to go into the target group here. Here is the target group, and it is showing now as set as health state as initial. So we have to wait for it to be configured. So how much time we have to wait? 14 seconds. So let us go and wait for it. Okay, Aditya, I think you have joined little late. Please go through this. A load balancer is a device which will route your traffic to multiple targets, multiple targets which are sitting behind your load balancer. So it does load balancing of the application coming to your web server or your e-commerce server or your any kind of any servers. So just go and look at the recording. Okay, so let us go and check the targets. Yeah, so it is still showing target registration in progress. Yeah, fine. Hold on. Let's wait. So it is showing 3 in initialize, and it is still not showing healthy. We'll wait for this. So at times it will show you more time for registration. So don't worry, we'll wait for it. Okay. And meanwhile, I go into the load balancer, and there is a tab here called as listener. Now, I told you earlier, this PPT, that with our load balancer, we can have multiple target group like this target group and have multiple health checks and listener. So that is evident from this screen. Yeah, you can see there is a one listener which is added. You can add multiple listeners and so on. Okay. So our machines are showing healthy, and that means now I can start using my load balancer. Okay, so go to your load balancer, take the DNS name of your load balancer and paste it in the browser. So I'm just closing all these windows which were I have opened earlier, and I will just paste it here. Okay, and here it is. Okay, so it has gone to one of the IP address. If I just do a refresh, it went to the second IP address now. And if I again refresh, it went to the third server. Okay, one second server and the third server. So this is how your load balancer works and how we configure our application load balancer. I hope this is clear now. So if you don't have any questions, we will move to the next part. So this is what we have just covered. Yeah, this is done. This is done. This is done. There are more things to the load balancer, lot many features. Yeah, but and as part of this, we'll not be able to dive more details into it. For example, there are certain features like what you can say, header based routing, yeah, or what you can say, connection draining, all those things. Okay, that is possible with your application load balancer. It is also possible with your classic static IP addressing, which is only possible with your network load balancer. Okay, so that's it. So we have just finished load balancer, and we have already seen the auto scaling group yesterday. So that concludes our what you can say, the EC2 instance, and we will move to another section which is called as VPC, virtual private cloud. Now, what is virtual private cloud? We'll see now. Okay, let's go ahead. So before we move to the virtual private cloud, we need to understand few things. Yeah, things like what is IP address, what is a private IP address, what is a public IP address. So I will just give you a brief introduction of those, and then we'll move to the VPC section. So private IP address, any device which is on internet, any device will have a IP address. IP address is nothing but a, a, a combination of four octets, which will give you a IP address to your machine. Every device will have a private IP address at least. So this private IP address and public IP address will be um, associated with that particular digital device. It can be your laptop, it can be your tab, it can be your desktop as well. Nowadays, there are devices which are internet enabled IoT devices that also have a IP address associated with it. So that is the IP addresses. So there are two types of IP address. One is called as public IP address, one is called as private IP address. Public IP address is used when you want to connect your machine to the internet. Yeah, so if you want to connect your machine to the internet, then you need to have a public IP address. Private IP address is only available within your own private network. So that is the private IP address. Private address will work in the local network. Public IP address will work outside of your network. Public IP address is not available by default. You have to request it by your internet service provider. And this is a table which distinguish between what is private IP address, what is public IP address. When private IP address is free of cost, public IP address is costly. It has some cost. Yeah, whenever you want to use a private IP address, we will be able to only communicate within your network. But with public IP address, we will be able to communicate on the internet. There is only this specific range of IP address for your private IP address. Any IP address which is outside of this is a public IP address. Now this range, we are talking only of IPv4 IP address. Okay, we will see what is IPv4 and what is IPv6. Okay, we will see that as well. So this range 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, and 192.168.0.0 to 192.168.255. This is the only range of private IP address. Any IP address Beyond this is going to be a public IP address. So let us go. What is that? Okay, that can be checked by using this two website. Yeah, this one and this one. Let me go and open that website. I will show you that. Okay, CIDR.xyz. So what is CIDR? CIDR nothing but it is called as classless classless inter-domain routing protocol, which will help you to what you can say, divert the traffic to this IP addresses. So IP address will have maximum of 4.3 billion IP address. And it is denoted by 4 octets of 3 decimal digit each. So the maximum decimal digit you can have is 255. 255. Every octet will have maximum 255, or which translate into 256 count, because it starts with 0. Okay, so like this. The maximum IP address you are going to have is this value, which is 4.3 billion IP address. Okay, in this case, what happens is this value will govern what are the number of bits which are going to change in that IP address. If you translate this 3 decimal digit into binary, it translates into 8 bits, 8 bits, 8 bits, 8 bits. So how do we derive to this maximum value? It is nothing but 2 to the power 32. Yeah. So if I say 2 to the power, let's say 16, which will give me 65,000 IP address. Now in this case, if I just post 24, so it is something like 2 to the power 32 minus 24, which is 8. That is 2 to the power 8, which is going to give you 256. In this case, what happens is all these values in the first 3 octet will remain constant, and only last 8 values are going to change. And that's the reason we are going to get 256. Now, because of the number of IP address we are getting with IPv4, which is 4.3 billion IP address, this IP address are falling short of the numbers, okay, number of devices which are available in the world. And that's the reason there is another IP address scheme which is called as Ipv6, okay, CIDR v6.xyz has came into picture, and which is called as Ipv6 Ip Addressing. So this Ipv6 IP addressing is divided into a group of 8 group of 8 of 16 bit each, which is nothing but this number represent a combination of 4 hexadecimal number. Yeah, so this value can be a hexadecimal. Now hexadecimal is what? It is a combination of 0 to 9 and then A, B, C, D, E, F. If you look at the combination of this IP address, the maximum IP address you are going to get from this is this value. I cannot even pronounce what is the count here. Okay, now this is the IPv6. Because our IPv4 IP address were falling short, that's the reason IPv6 was introduced. In IPv6, there is no concept of public and a private IP address. All IP address are public IP address. So this is your IP address schema. So I hope you are able to understand it. You can go and look at more details about this. So now, okay, why we have just understood this IP address, public IP address, private IP address, and so on. Now, whenever you are using your AWS environment, AWS is providing you your own private isolated network on the cloud. And that is done by your VPC, virtual private cloud. By doing that, your environment will be isolated from any other environment on the internet. When you have your own private IP address, virtual cloud in your private network in the AWS cloud, you can set your own IP address range for your private cloud. You define what is the IP address range I am going to do. Now remember, this is a private network. That means you have to stick within the limit of these 3 ranges only. So by default, VPC is going to give you that range. Yeah. And this is how your complete VPC will look like in the AWS environment. This is your VPC. Within that VPC, you will have your subnets. Okay. Each subnet will span across one AZ. This is, you can see your AZ, AZ-A and AZ-B. Then you can install your EC2 machine in that. And for that to work properly, we need to have various components. We will see that in the later slide. Okay. So let us look at another diagram. Yeah, this is also a same diagram, which is more detailed, where you can see the security group, network ACL, route tables, internet gateway, and so on. So we will try to configure it. If we get time, I will show you complete demo of it. Yeah, or otherwise, I will just show you a automated way, which we can do from our VPC section, VPC service. So let us go and move next. So whenever we create a VPC, we have to remember certain things. Yeah. So I want to just go and highlight this part first before we go to components. Yeah. So there are certain things when you work with your AWS VPC, you have to remember that. Okay. So the maximum IP address range you can have within a Amazon VPC is this. You can have maximum /16 and minimum /28 IP address range. Yeah, for this is for IPv4, and for IPv6 it is /56. You can bring your own IP address. Okay, when you go and use the IPv6. Yeah, because IPv6 are not free of cost, so you have to go and bring your own. Yeah, so by default, whenever you create a VPC in your environment, IPv4 VPC is created. Okay, and you have an optional choice of IPv6 VPC to be created. So you cannot create a IPv4 enabled EC2 machine in a IPv4 IP address VPC. Okay, so you have to remember that. Now with IPv4, all AMI's EC2 instance will be supported, but you need to be aware whether the IPv6 IP address is supported by all AMIs. Within the VPC with IPv4, you get something called as elastic IP address. Elastic IP address are nothing but the static public IP address within your VPC. With IPv6, it is not supported. There's no static IP address. Then there are certain devices which are supported. For example, a NAT gateway is supported. Yeah, a NAT instance is supported in IPv4, but in case of IPv6, we have to use something called as ingress only internet gateway. Yeah, so we have to remember that. Okay, so let us go and look at the component. The first component I'm going to look at is the subnet. Now, what is subnet? So we have just seen the CIDR block here in the IPv4. Now this CIDR block is one, let's say a VPC CIDR block. Let's say it is /16. Let us put like this 10.0.0 and then /60, which means this two will keep the same and this will change. Now what I'm going to do is, yeah, this is complete huge range. Yes, this is the 65,000 IP address we are going to need. But I want to divide this into small sections to host my public facing machines, to host my private facing machines, and yeah, and to host my databases, which should be in my private machines and so on, private instance. Yeah. So for this, what I am going to do is I'm going to create a logical separation between this IP address range. That logical separation is called as a subnet. So subnet is nothing but a logical separate, a segment of IP address within your VPC, which will create an isolated resource for you. Generally, we isolate this based upon public subnet, private subnet, and maybe another subnet like database subnet and so on. Okay, so subnets are nothing but a logical grouping of your VPC CIDR block. Now, whenever you want to connect a EC2 machine to the internet, we need a device called Internet Gateway. This will provide you a public connectivity to your virtual machines, which is their EC2 machine. Yeah, any machine which has a connectivity to the internet via the Internet Gateway, that machine will be part of a public subnet. Remember one thing. A public subnet is called public subnet because it has an internet gateway associated with it. And from there, you will be able to connect to the internet. So remember that. So this is the internet gateway, which will provide you a connectivity to the internet. Next is NAT gateway. What is NAT gateway? Suppose you have a virtual machine which needs to be in your private subnet. Now, private subnet will not have any internet connectivity for it. But suppose you have a database in your private subnet and now you want to connect it to the internet for downloading certain packages. Because your private machine does not have any internet connectivity, how it will connect? So what happens is you use another device which is called as NAT gateway. This NAT gateway is highly available, what you can say, highly available, highly resilient device which will provide you access to the internet only for your private subnet resources. In doing so, what it does, it creates a one-way traffic. That means your machine which are in private subnet will be able to go to the internet, but anybody from outside will not be able to connect to that particular private machine. And by doing so, we are protecting our private machines. Why? Because we don't want to access to the internet. So this is the functionality of a NAT gateway. So for this NAT gateway, we need to create this NAT gateway in a public subnet, and then we need to add a route for this NAT gateway to go to the internet. Okay, and that will be only associated with your private subnet. So that way, any machines which is part of your private subnet will be able to have an internet access, but nobody from outside will be able to connect to that EC2 machine in private subnet. That is the NAT gateway for you. And this is a fully managed gateway from AWS. You don't have to worry about the high availability of it. Then we will see another thing which is called as virtual private gateway. Now, what is virtual private gateway? Whenever you want to connect your AWS, which is like this, let's say this is your AWS environment and your on-premise environment, this is your on-prem, then you need to create a connectivity between this. Okay. And this is done by, there are multiple ways. This is done by using a VPN connectivity. Okay. Now, to set up a VPN connectivity, you need two devices. One is called as VPG, which is virtual private gateway, which will sit on the AWS side with VPG. Yeah, so here it is VPG. And on here, on the customer, on the on-premise side, you will have customer gateway, CGW. Okay, CGW. Okay, so that devices are useful to set up the communication between your AWS and on-premise. So that is the AWS side of the router is called as VPG, which is virtual private gateway, and the on-premise side of a router is called as customer gateway. So that will enable you to have a connectivity between these two. Then when you want your one VPC to talk to another VPC, now I told you earlier, all VPCs are isolated. Yeah, so two VPCs will not be able to talk to each other. Okay, so if you want to make these two talk to each other, we need to create something called as Vpc Peering. By doing a Vpc Peering, you will be able to talk to each other, whatever the EC2 machines which are there a part of this, the VPC, they will be able to talk to each other by using a private IP address. And they are going to sit within your AWS environment. This traffic is not going to leave your AWS environment. Okay, So that is the peering connection for you. So you need to set up a peering connection, and this is free of cost. Okay, that's the peering connection. Now there's something called as VPC endpoint as well. What is VPC endpoint? VPC endpoint is nothing but a point-to-point connectivity from one of your AWS EC2 service to your another service. Okay, by doing so, we are not leaving the private network of our AWS environment, and we are not going to use any of the NAD gateway or internet gateway to communicate with that service. So that is the VPC endpoint for you. Other device which is called as egress only internet gateway. This is a gateway which will provide you ingress only access for the IPv4 traffic. So that is the ingress only gateway. So this is only used when you are having IPv6 kind of a your VPC. Fine. So this I have already covered. Yeah. So now I will come to another point. Before going to there, I will just take a couple of minute break for a water. I will be back in a minute. Give me a minute. Okay, I'm back. Yeah. Now we move to another very important part, which is what is a default VPC and what is a custom VPC. So let me just look at this. Okay. So now whenever we have created our EC2 instance, we have used a network. Yeah, we have used a VPC. That VPC which is ready for us to use is called a default VPC, and that is created for everybody whenever we have created our AWS account. So I will show you VPC here. VPC. Where is the VPC? And this you will see the default VPC. If I go to the VPC here, and it will show a default VPC. How do you distinguish this is a default VPC? First of all, any AWS account, whether it is my account, your account, the CIDR block for a default VPC will be this only: 172.31.0.0/16. And other way to recognize it, if you move here, and it will have a column called default VPC, which is set to yes. Now the advantage of this default VPC is like this. So default VPC is created for you and it is ready to use. You don't have to do any changes in this, and you will be able to communicate to the internet without any issues immediately. And that is what we did when we created the EC2 machine in it. But on the other hand, okay, this custom VPC is the VPC which you as a customer is going to create it. You will choose your own IP address and you need to configure all the details what we have just seen, the components of our VPC. For example, we have to create an internet gateway. We have to create a NAD gateway. We have to create a routing for it, and so on. So that is the custom gateway for you. This is what every customer does in the AWS environment. Nobody will go and use the default VPC. Everybody will have their own custom VPC. The custom VPC, default VPC is created by AWS. It is the custom VPC is taken care by the customer. Whenever you create your whenever you create your AWS account, this default VPC is directly assigned. Custom VPC you have to create. In your default VPC, you will get a public as well as private IP address by default. But with your custom VPC, you will not get that. Okay, so you will not get a public IP address. Private IP address will be there. Internet access will be available. Here it will know. You have to go and configure. Yeah, and there will be only one default VPC per region, but you can have 5 custom VPC per VPC per AWS region. Okay, so that is the difference between your custom VPC. If you need to increase this default number of custom VPCs, then all you have to do is to just raise a ticket with AWS, and they will be able to give you that a number of VPCs in your environment. So that's the default and a custom VPC for you. Then I want to also show you one more thing. Before with that, I will just go and show you how to create a custom VPC. I will give you a quick demo of automated way of doing it, which is available in AWS. There is a more detailed way of doing it, but that requires more what you can say time, effort, and so on. So let us go and create a custom VPC. So here is how do I start? I go here into my VPC dashboard and I can just say create VPC. Yeah. So here is the custom way of the automated way of creating it. Yeah. So here you have 2 options. You can just create VPC only, or you can say VPC and more. And then you have to give a name for your VPC. Here it is. I have to give a CIDR block for my VPC. Let's say I am giving this CIDR block and I'm not selecting any Ipv6 IP address. Then it is asking me number of availability zones. So I can select, I need just 2 availability zones. Yeah, a number of public subnets. I can put a value here. I can create 2 public subnets and 2 private subnets. Fine. Number of NAT gateway I can select. So I can say 1 in each. I can do that. Yeah. And I don't want to have a VPC endpoint at this moment. And then certain settings, for example, enable DNS hostname and DNS resolution. By doing this, what will happen? Any EC2 machine which I am going to create in my VPC will have a DNS name by default. So this is how my environment will look like. Okay. So in this case, one VPC will have 4 subnets, 2 public subnets, 2 private subnets. So 1 in this AZ, 1 in this AZ. Then whenever we want to use our VPC for routing purpose, we need to create a route table as well. By default, whenever we create a VPC, it creates one main route table, which we can use, but as a best practice, we should not use that main route table. And instead of that, we should create another route table for us. Yeah, then these are the route tables which are created. And then based upon that route table, we have to create a internet gateway for our internet access and a NAT gateway. Now remember one thing, whenever we are going to create a VPC, we can attach only one internet gateway to our VPC. Yeah, we cannot have more than one internet gateway attached to our VPC. So with this configuration, let's go and create our VPC. Yeah. So this is a very simple way of doing it. But if you want to do all of this, there is more complex or more step-by-step things to do. Let us go and create it. Okay, here it is. So it will go and create all the resources for you. So now in this case, it has created, it has taken its own cyber, the CIDR range for the subnets. There is an option for us to go and select the CIDR range, but at this moment, we have just gone with the default way of doing things. Okay, so let this come. Meanwhile, I am ready to take the questions if you have any questions. Hmm? Anybody? Okay, fine. So let it run. So you will understand how simple it is actually to create this way. What I will do in next class, I will show you the manual way of doing the things. Then you will be able to understand more things in a better manner. Hmm? So let us try to do that at the next class. Yeah, we might spend 1 hour for it, but uh, Nirek Shah, what is this modulation you are trying to ask here? Okay, I do not know what modulation you are asking. Please, can you explain what is that you're trying to understand here in this class? Okay, so our VPC is done. Let us go and view our VPC. Okay, so I told you whenever a VPC is created, we get by default a route table, main route table. We also get something called as network ACL, which is network. This is the firewall at your subnet level, and we also get something called as DSCP scope. So we'll see that. Okay, so this is what we have created. We have created when now we have also created a subnets in our VPCs. So here it is. So if I just filter out my VPC based upon the VPC ID, what is the VPC ID here? Okay, here it is. This is my custom VPC. So you can see there are 4 subnets. I just filter out private 1, private 2, public 1, public 2. Now in this case, this whatever the IP address, it has taken in the CIDR range which I have. So yes, Rohit, whatever we have done, we have to host the website onto a EC2 machine, and your EC2 machine will reside in a VPC. So yeah, that's how it is done. So here I can see that this is the CIDR range for the subnets taken care by your AWS environment, and it is going to give you 4096 IP address. But in this case, you can see here we have 4091 IP address. Now, why this has happened, I will tell you in the next class, because there are 5 reserve IP address in each subnets which cannot be used, and that's the reason we see less number of IP address here. Every the subnets are associated with some route tables. Let us go and see the route tables here. There it is. So again, I will filter it out based upon the VPCs. Yeah, you can see. Okay, there are route tables here. Okay, so one is this private route table. This is one private route table, and this is one public route table. Now, I told you that public subnets will have a route to the internet. Yeah, and that's how we will be able to uh, connect to the internet. So let me show you that. Okay, I go into this route table. When I talked about the route table, I said there is a route to the internet. How do you do that? This is done by using the route tables. You can see here, this is the route. I do edit route here, and you can see that I have a route to 0.0.0/0, which is your internet, via internet gateway. Okay, this is the internet gateway for you. Don't worry, we will see that practical in the next class. So here is the internet gateway, and because of this, you are able to go to the internet. Okay, I will say cancel. This is one setting. The second setting is the subnet association. Unless and until you do the subnet association, which is for the public subnet, you will not be able to route the traffic to the internet. So these two things are very, very needed when you are going to use the route tables. So routes and the subnet association. So this is for your the route table. Now let us go and look at the internet gateway as well. So here you can see there is the internet gateway, and this internet gateway is attached to your VPC. Now we also created a NAT gateway. So let us go to the NAT gateway. Here is the NAT gateway. Okay. So you can see a NAT gateway, and if I look at the configuration of the routing for the NAT gateway, I will go into this route tables and look at that. But before I do that, whenever we create a NAT gateway, what we have to do, we have to attach a elastic IP address, a static IP address to our route table. A static IP address to our route table. What we'll do, and then we have to add that route table in our public subnet. So you can see that it has taken a subnet as the public subnet. Here you can see. This is the public subnet for you. So that's it. Then let us go and look at the route table of our private subnet. Here is my route table for the private. So you can see there is a route to the internet, which is 0.0.0 via the NAT gateway. And if you go into this, there will be one subnet association. Correct. This is for the private 2, because this route table is for a private 2 subnet. And if I go into the private 1 subnet route table, then you will see there is a route via the same NAT gateway, but this time the subnet association will be this one, which is private 1. Okay, so this is how your end-to-end, what you can say, subnet VPC creation is done. Okay, this is automated way. Now let me tell you the manual way of doing things. Yeah, and that will become more clear for you. Okay, so before we do that, we need to do a planning. And how do we do the planning? Based upon the VPC CIDR. So let me just go and give you that planning details. So let's assume that we want to create a VPC. Yeah? We will just do the planning here, and we will do that the VPC creation tomorrow. We will just start it. We will create VPC. We will create subnets, and they'll stop for today. And next thing we will do it tomorrow. So for planning, we need to have a CIDR range of our VPC, which is 10.0.0.0/60. This is going to give me 65K IP address. The second thing I have to do, I will create subnets in it. Let me assume that I will create 2 subnets here. Public subnet 1 with the CIDR range as 10.0.1.0/24. Okay, and this is going to give me 256 IP address. Then I will say a private subnet, and this is, I'm going to give a name subnet 1. And for this, I'm going to give another IP address range, which is 10.0.2.0/24. And this is also going to give me 256 IP address. Okay, fine. So this is the planning we have to do. Now, why this planning is needed? Because that is going to govern how many devices you can, maximum device you can have. So here in this case, 65,000 is the maximum device I can have. In the public subnet, I can have maximum 256 IP address or devices, and in private subnet also 256. But because we have created a small range of subnets, we can add multiple subnets here like this. So let us go based upon this, create our VPC and the public subnet. The step number 1, go to VPC and create a VPC. So I will go one by one step. Step number 1, create VPC. And this time we are going to do the manual way of. I will give a name First of all, yeah, because we already have a VPC with this CIDR range, we have to use another CIDR range. Okay, let's do that, because we cannot have a block, what you can say, same CIDR range. Yeah. So how do you do that? Either I use this, I delete this, or use different one. So I will do a delete of. For that, I need to first delete the resources. Okay, so I will delete first the NAT gateway. This is how you do it. Delete NAT gateway first, because I should not have any devices in that particular environment uh, before I delete that VPC. So let me just go and delete it. So as soon as I delete it, this elastic IP address will be released. Yeah. And I have to deassociate that as well. Okay. Fine. Let us wait for this to be deleted, and then we'll start that the other things. So I am open for questions. If anybody has a questions, please paste and ask. Yeah, please go ahead. Okay, Niresh, I would say you are not what you can say. This class is not about modulation, Niresh. Okay, so please do not post such kind of questions. This is irrelevant for this class. Yeah, thank you. And no, Chandra, we are not going to have class in the weekends. It is just weekdays we are going to have. Okay, so this is deleted. If I go to here, I can release this. Yes, so release. Let me just release this. Anybody else who has questions? Yes, let me release it. Very good. Done. I go to my VPC and delete that VPC. Action and delete VPC. Remember one thing, never ever delete the default VPC. Okay, remember that. If you delete the default VPC, you will not be able to create it again. Okay, so you have to go and ask AWS to assist you to create the VPC. Fine, default VPC. So here is now I have deleted the other VPC. Okay, so back to our exercise of creating a VPC in a manual way. The first thing is we will create a VPC. Create VPC. Give a name. ExcelR. ExcelR CVPC. I will name it Custom VPC, and I will put the IP address as well here, so that it is easily recognizable for me. Yeah, and then I have to put this IP address range in the actual IP address range I'm going to use. And I don't want a IPv6, and that's it. I will create a VPC first. Done. As soon as I create a VPC, a main NACL and main route table and DSC scope is created. But I do not have a subnet, correct? Because these are the subnet from the default VPC. Let us go and create this two subnets. Here is step number 2. Create two subnets. Step number 2, create two subnets. What you have to do? Go to your subnets, select your custom VPC, which you have just created, and give the name for your subnets. So first subnet is I'm going to create is public subnet. Subnet, and this is going to be 1, and the IP address for it. 0/24. Okay, this is just a name. Okay, don't get confused, because name and the CIDR block should be different. Yeah, should be given separately. So this is name, and whenever you create a subnet, you have to associate it with the AZ. So I'm going to associate it with 1A AZ. and the CIDR block for your this subnet. Fine. So my public subnet is now done. Okay. So please remember to select the right VPC to when you are creating a subnet. Create subnet again. Select the VPC. Give the details like this. Private subnet, and I will just say it is 2 dot, yeah. And this time I'm going to select another AZ, which is 1B, and the CIDR block I'm going to put it here, which is 2 dot, yeah, 2.0, and create subnet. Okay, so step number 2 is completed. If I go and look at my VPC subnets, so here it is. Okay, so I can see now there are 2 subnets. And all of them have 251 IP address because 5 IP address are reserved per subnet. So step number 1, step number 2 is done, and we will stop here for today, and we will meet on the Monday. If anybody has any questions, I am ready to take the questions. If not, we will end the class in next 1 minute. You can change the subnet if you are talking about editing it. Okay, you can do that like this, but the CIDR block cannot be changed. Okay, but yes, you can, if you want, you can add new subnet as well. Okay, Aditya. Anybody else? I hope I answered your question, Aditya. Okay, thank you. Anybody else? Yeah, I will wait for 1 minute, and if no questions, then I will end the class, and we'll meet on Monday. Okay. Thank you very much, and we'll see you on Monday. Okay, bye bye.